Imagine a high security vault where the guards at the front door don't actually check your face.
Right.
They don't check your fingerprints. They just, glance at the plastic ID badge you printed at home. And if the logo on that badge looks real, they smile, open the doors, and hand you the gold.
It's terrifying when you put it like that.
It really is. And welcome to today's deep dive. We are adopting the Cyber Mornings daily briefing format today, which means our mission is to deliver a really concise, high-impact look at the top 3 cybersecurity stories of the day.
Exactly.
And looking at the intelligence we've gathered for you, a truly terrifying theme is emerging here. We are seeing the absolute weaponization of implicit trust.
Yeah, the front door is basically irrelevant now.
Right. Attackers aren't just breaking down the door anymore. They are forging the badges of the infrastructure we already rely on. So they're turning standard website forms, highly secure payment processors, enterprise cloud servers, all of it into their own malicious playgrounds.
That's exactly the framework we need to be using today. This deep dive is about giving you clear takeaways and practical impacts. Because if we just look at a list of technical vulnerabilities, we miss the forest for the trees.
Definitely. It's just noise at that point.
Right. We have to look at the mechanisms. We need to understand exactly how threat actors are operationalizing these flaws at a massive scale. They are taking implicit trust, which is literally the foundation of how the modern web operates, and they are turning it completely upside down.
Okay, well, let's get right into our first story, which looks at a threat we're calling the hidden infiltrators.
Uh-huh.
So, we have a critical vulnerability in a WordPress plugin called Everest Forms Pro.
Oh, yeah, this one is nasty.
Yeah, it's tracked as CVE 2026-3300. And it carries a severity score of 9.8 out of 10.
A literal 4-alarm fire.
Exactly, especially for the, I think it's 4,000 websites actively running it. But what really stands out in the sources is the mechanical breakdown of how this exploit actually works.
Well, the mechanics are fascinating and honestly a bit of a nightmare for developers. So the vulnerability exists in a specific part of the plugin called the calculation add-on.
Okay.
Imagine you have a website selling custom t-shirts and you use a form to calculate a price based on the number of shirts, the colors, and, the shipping distance. The plugin uses a function named process filter that's with an underscore to handle that math.
Makes sense so far.
Right, but here's where it goes off the rails. It takes the values a user types into the form, stitches them together into a PHP code string, and then passes that string directly into a native PHP function called eval.
Oh, wow.
Yeah. For anyone who has ever written a line of PHP, seeing eval used on user input instantly sets off alarm bells.
Because it just runs whatever you hand it.
Exactly.
Yeah.
That function basically tells the web server, take whatever text is in this string and execute it as if I programmed it myself.
Okay, let's unpack this. So if I understand this, it's like a bank teller taking a deposit slip from a customer. And instead of just reading the deposit amount, the teller enters whatever the customer wrote directly into the bank's mainframe.
That's a perfect way to look at it.
So if the customer literally wrote the code to transfer $10,000, the system just blindly does it. But wait, surely the developers knew they couldn't just pass raw user input into an execution engine. There has to be a filter.
You're right, and there is a filter. They tried to do the right thing by using a built-in WordPress function called sanitize text field.
Okay, so what went wrong?
Well, here is the critical failure. That specific sanitization function strips out certain bad characters, but it does not escape single quotes.
Oh, no.
Or other context characters used in PHP code. So, if an unauthenticated attacker puts a single quote in an email address field, they can essentially break out of the expected data format.
Just by using a single quote.
Just a single quote. Because of that one oversight, anyone on the internet can inject arbitrary PHP code via any text-based form field, as long as the form is using that complex calculation feature.
So the attacker just visits the contact page, fills out the form, and suddenly they're running code on the server. What does that actually look like out in the wild?
We are seeing massive real-world exploitation. Attackers started hammering this flaw on April 13th, 2026. Security researchers have tracked over 29,300 blocked attempts so far.
Almost 30,000. That's huge.
Yeah, and the payload is almost always the same. They use that code execution to quietly create a rogue, invisible administrator account named Dixie Marina.
Dixie Marina.
Yeah, tied to a specific Dixie Marina Gmail address. Now, the developers did release a patch version 1.9.13 back on March 18th.
But people are slow to patch.
Always. Attackers know organizations are slow, so they are actively hunting for those 4,000 vulnerable installations.
So the lesson there is clear, patch your forms immediately. But the sources highlight another layer to this story that completely shifts the landscape.
The SANSEC report.
Yes, SANSEC released a report about attackers using Stripe as a command and control server. And I'm honestly hung up on that premise. Wait, the sources mention attackers are using Stripe as a C2. How is an attacker hiding inside one of the world's most trusted payment processors? Stripe's whole business is security.
Right, but they aren't actually breaking into Stripe's internal network to steal money from Stripe's corporate accounts. That's the brilliant part.
Okay, so what are they doing?
They are treating Stripe's public-facing architecture as free, implicitly trusted infrastructure for their own malware. They aren't even laundering fraudulent credit card charges either.
Wait, really?
Really. Instead, they are using Stripe's API, along with Google Tag Manager, to completely bypass content security policy rules.
Okay, so CSP, which is basically the bouncer for your browsers, like a VIP list that a website sends to the browser saying, only load scripts or send data to these specific pre-approved domains.
Exactly.
And I'm guessing GoogleTagManager.com and API.stripe.com are on almost every single e-commerce site's VIP list.
Of course. If you block Stripe, your checkout page breaks, and you can't take payments. Attackers know that. So, on Magento and Adobe Commerce checkout pages, the attackers compromise the store and use Google Tag Manager to load their initial malicious code.
Neat.
Very. That code reaches out to a completely legitimate but attacker-controlled Stripe customer profile. It has a standard ID like cust.ffj, whatever, just a normal ID. The attacker has taken an obfuscated credit card skimmer and pasted the code directly into the metadata text field of that Stripe customer profile.
My God.
Yeah. When the browser asks Stripe for that customer's profile, the trusted Stripe API happily delivers the skimmer right past all the network firewalls and CSP rules.
That is incredibly devious.
Yeah.
The firewall sees data coming from Stripe and just assumes it's totally safe.
Uh-huh.
So now the skimmer is sitting on the shopper's browser. The shopper types in their credit card number. How does the attacker get that stolen card number back out without triggering an alarm?
Well, when you type your card into the checkout form, the malicious script temporarily saves it to your browser's local storage.
Which is usually where websites save your shopping cart so it doesn't disappear if you refresh, right?
Exactly. The script takes the financial data, the billing address, the phone number, packages it all up, and sends an update request right back to the attacker's Stripe account via the trusted API.
Wow.
Every stolen credit card simply becomes a new customer record in the attacker's Stripe database.
So they're using Stripe's customer database as a highly durable exfiltration sink. The network defenders are never going to block outbound traffic to Stripe because that's how the legitimate store processes its own payments.
Precisely. And once the data is sent, the script deletes the local storage entry so it doesn't send duplicates. And this tactic is being deployed at an industrial scale.
Right, the Gorgon Agora campaign.
Yes, the sources detail this massive operation called Gorgon Agora that has been active since August 2025. They aren't just compromising existing stores, they built an empire of fake ones.
Fake storefronts.
Yeah, they registered over 5,700 fake storefronts ending in the .shop domain, perfectly impersonating massive brands like Starbucks, Lego, and Disney.
Over 5,000 stores. The infrastructure to run that alone must be massive.
They streamlined it perfectly. Every single one of those thousands of stores runs on the exact same Medusa.js commerce stack. They load a custom checkout software kit that renders what looks exactly like a secure Stripe payment window.
But it's not.
No, it's an iframe controlled by the attackers. When you type in your card, they steal the data and instantly exfiltrate it over a highly encrypted WebSocket to a single command server located in Moldova.
And why Moldova?
Jurisdictional arbitrage. It is notoriously difficult for Western law enforcement to seize servers or get cooperation in certain jurisdictions, which gives the attackers a safe haven.
That makes sense.
But the most sophisticated part of Gorgon Agora isn't the server location, it's how they defeat the banks.
What do you mean?
Let's say a victim's bank flags the transaction as suspicious and demands a 3D secure challenge.
Right, that's when your bank texts you a 6-digit code to your phone to confirm a purchase.
Exactly. The attacker server in Moldova detects that challenge and establishes a live relay. It proxies that 3D secure challenge directly back to the shopper through the fake checkout window.
Oh, wow. So the victim is sitting on their couch, they get a legitimate text message from Chase or Bank of America. They look at the code, they type it into the fake Starbucks site, thinking they're just verifying their new coffee mug.
But the attacker intercepts it.
That is wild.
And the attacker instantly forwards that code to the real bank to authorize the massive fraudulent theft they just initiated in the background. The victim feels totally safe because the SMS came from their actual bank, but they are actively approving their own robbery in real time. It stays completely invisible.
Okay, so the previous story was about attackers breaking into infrastructure to steal data out of it.
Yeah.
The Gorgon Agora attackers are hiding behind trusted checkout pages, but that's really just the front end of the operation.
Yeah.
Because sometimes they don't care about your data at all. They just want the pristine reputation of your cloud servers to launch their own operations. To run an empire of 5,000 fake storefronts and real-time relays, they need pristine, high-performance back-end infrastructure.
Which is exactly what we are seeing in our second story. We are looking at an operation run by a threat actor known as PCPjack.
PCPjack.
Yeah. They have successfully hijacked 230 enterprise servers across Amazon Web Services, Google Cloud, and Microsoft Azure. And what's crucial here is their motive. They haven't breached these corporate servers to steal the company's internal data or intellectual property.
No.
No, they broke in to quietly convert these compromised business servers into a covert SMTP email relay network.
Here's where it gets really interesting. It's like an unauthorized subletting operation where the squatter checks the plumbing before renting the apartment out to spammers. But I have to ask about the economics of this. If a group like PCPjack manages to get root access to 230 cloud servers across major providers, why settle for sending emails?
You'd think they'd want a bigger payout.
Right. Why not deploy ransomware and demand millions of dollars, or at least spin up crypto miners and make a quick buck?
It all comes down to the immense market value of digital reputation. If a spammer tries to send 1 million phishing emails from a known, cheap, bulletproof hosting provider in some sketchy jurisdiction, the spam filters at Gmail and Microsoft 365 will block them instantly.
Because the IP is dirty.
Exactly. The emails will bounce before they ever reach an inbox. But if an attacker routes those same phishing emails through a pristine, highly trusted AWS or Azure IP address that legally belongs to a Fortune 500 company,
Oh, I see.
those emails sail right past the spam filters because the sender's reputation is flawless.
So they are essentially laundering their malicious emails through a trusted corporate IP. The company pays the Amazon server bill, and the attacker reaps the rewards of a perfectly delivered phishing campaign. How did this get uncovered?
Hunt.io uncovered this entire operation because the attackers got sloppy. They left the digital doors to their command server wide open to the public internet.
Unbelievable.
Yeah, 2 directories were left completely unauthenticated, giving researchers a direct look at their playbook. And the profile of PCPjack is fascinating. Sentinel alone actually first spotted this group back in April 2026.
And what were they doing back then?
They were using a credential theft framework that was actively hunting down and terminating competing malware from a rival group called Team PCP.
Wait, really?
Yes, it is literal gang warfare playing out silently inside compromised cloud environments.
So researchers get access to the command server. What exactly did they find inside those open directories?
A highly automated, exceptionally professional toolkit. They found a custom SMTP proxy deployment kit integrated with Sliver.
Right, Sliver. That's a powerful open source framework usually used by legitimate red teams to simulate attacks, but here it's been weaponized.
Exactly. They also found tunneling software called Chisel with binaries compiled for almost every Linux architecture, AMD 64, ARM 64 by 86 per man. So it didn't matter what kind of server they breached, they had the right tool.
They were ready for anything.
Yep. Once PCPjack breaches a server, they drop a hidden file and establish a permanent backdoor in the vartopt directory. It's saved as a .exis file to keep it hidden.
And the sources outline a specific step in the deployment script called a quality gate, which I find brilliant from an attacker's perspective. It's essentially an automated job interview for the malware.
That's a great way to put it. As soon as the newly compromised cloud server is infected, the deployment script forces it to attempt a connection out to Gmail's mail servers, specifically on port 587.
It's probing the corporate firewall to see if outbound email relaying is allowed.
Exactly. If the host fails that check, meaning the company has properly locked down its outbound traffic, the malware just uninstalls itself and moves on. The attacker doesn't want it. A server that cannot quietly relay email has zero value to their pipeline.
It's ruthless efficiency.
Very much so.
For the servers that do pass that test, they are verified as usable proxies. And the script assigns them a specific port derived mathematically from the server's unique ID and MD5 hash of their Sliver UUID. I think so. It always connects on the exact same port every time.
And the automation doesn't stop there. There is a background script testing these active compromised tunnels every 60 seconds to make sure they're still alive and functioning perfectly.
Every minute.
Every single minute. Then, every 5 minutes, this pristine list of 230 trusted proxy nodes is synced via SCP to a downstream server. Presumably so, an unknown end consumer like a cartel or a massive phishing operation can start blasting out campaigns.
The takeaway here for cloud administrators is critical. Cloud security is not just about blocking inbound threats. You have to aggressively monitor your outbound traffic. If you aren't watching your outbound mail ports, and if you aren't actively hunting for hidden .prefixed files and temporary directories, your expensive, trusted cloud infrastructure might have already been drafted into a botnet.
Exactly, but to build that kind of massive cloud infrastructure, attackers need to find vulnerabilities that give them the absolute keys to the server in the first place.
Right. PCPJack relies on finding vulnerable servers to build its army. And our last story for you today looks at exactly the kind of deep network enterprise flaw that gives attackers the keys to the kingdom.
So instead of focusing on the cloud perimeter, we're looking at how attackers achieve total compromise from the inside out by abusing the internal trust of enterprise applications.
So we were looking at Cisco Unified Communications Manager, specifically CVE 2026-2230. Cisco just patched this flaw. It's an SSRF, a server-side request forgery vulnerability, in its Unified CM and Session Management Edition. Now, looking at the threat scoring, there's a huge discrepancy that we need to talk about. The bug is rated an 8.6 out of 10. That's high, but technically not critical. It's rated 8.6 because the vulnerability itself supposedly only allows arbitrary file writes. But Cisco's own advisory slapped a critical warning on it. It feels like raiding a Trojan horse is mostly harmless just because it's made of wood, completely ignoring the soldiers hiding inside.
I love that analogy, and Cisco is absolutely right to label it critical. The CVSS score of 8.6 is technically accurate based on a strict reading of the initial flaw, but it completely fails to capture the practical reality of the exploit.
I'm trying to wrap my head around how SSRF actually works here. It sounds like a receptionist at a highly secure building. The receptionist won't let a stranger pass the front desk. But if that stranger hands the receptionist a sealed envelope and says, "Please put this directly on the CEO's desk," the receptionist just does it without checking inside because the CEO trusts the receptionist.
Yeah, that's exactly it.
The attacker's using the server's own internal trust against it.
A perfect analogy. Because the unified CM software fails to properly validate the HTTP requests it receives, the attacker sends a malicious request from the outside, but forces the server itself to execute the file right on the inside.
Sneaking past the guards.
Right. The server bypasses its own security checks because the action is originating from inside the house. So the attacker writes a malicious payload file to the system. But that file write is just the foothold. Once the file is written, the attackers execute it and use it as a stepping stone to escalate to root access.
And root is game over.
Root is the absolute highest privilege on the underlying operating system. Once you have root, you own the box entirely. You can deploy those covert chisel tunnels we just talked about in the PCPJack story. You can steal sensitive internal communications. You have total control.
And the runway for defenders to fix this is practically non-existent. A proof of concept exploit blueprint is already public.
Unfortunately, yes.
While Cisco's internal security team hasn't seen it actively used in the wild yet, having a public blueprint means the countdown clock is ticking extremely fast. How does an administrator even know if they are exposed to this specific flaw?
Well, there is a massive mitigating factor that organizations need to check immediately. The SSRF flaw only works if a specific service called WebDialer is running on the unified CM server.
Okay, WebDialer.
Thankfully, Cisco ships the software with WebDialer turned off by default. But for any enterprise that has manually switched it on to enable certain calling features, they are completely exposed. Listeners need to audit their environments today.
Where do they look?
You log into the Cisco Unified CM Administration panel, switch over to the Serviceability tools, and look at the Control Center. If the Cisco WebDialer web service status says started, you are vulnerable and you need to act.
What does the patching situation look like? Because the sources indicate it is a bit of a mess depending on what software version a company is running.
The patching reality is unfortunately very fractured. If an organization is running older software, what Cisco calls the 14 train, there is a full software update, 14 SU6, available right now that fixes the problem entirely.
Yeah.
But if an organization is running the newest software, the 15 train, the full security patch, 15SU5, isn't scheduled for release until September of 2026.
Wait. They have a public exploit blueprint available today, and the fix isn't coming until September.
Exactly. And waiting until September is basically begging to be breached. So for anyone on that newer software, you cannot wait. You must either apply an interim temporary COP patch provided by Cisco, or you must go into the settings and manually disable the web dialer service entirely to kill the attack vector.
This feels like a recurring nightmare for administrators managing these specific communications platforms. It's not an isolated incident, right?
No, it fits a very troubling ongoing pattern for Cisco's unified CM platform. It has been a steady source of unauthenticated root-level vulnerabilities. Just last July, Cisco had to patch a flaw that was a maximum severity 10 out of 10.
A 10 out of 10. What was it?
Yeah, developers had somehow left a hard-coded root SSH account embedded in the production software.
Oh, man.
Then, in January of 2026, they had to patch an unauthenticated remote code execution flaw that was actively being exploited in the wild across their voice products. This new SSRF vulnerability is just the latest example of external requests that should never reach anything sensitive, doing exactly that.
The takeaway for our final story is urgent. Audit your Cisco environments for that web dialer status right now. Assume that an attacker is already trying to turn that file write vulnerability into a full root-level takeover of your network before you can deploy the patch.
Waiting to act is simply not an option.
As we wrap up today's briefing, the through line connecting all this intelligence is undeniable. Implicit trust is the modern attacker's greatest asset.
Without a doubt.
In our first story, we saw WordPress forums implicitly trusting raw user input and network defenders implicitly trusting massive domains like Stripe, allowing credit card skimmers to operate in plain sight. Then in our second story, we saw how the implicit trust placed in clean, corporate cloud IP addresses allows threat actors to build massive, invisible proxy networks.
And finally, we saw how enterprise services implicitly trust their own internal network requests, handing over the root keys to the server.
You have to verify everything. You have to assume the ID badge is a forgery.
And if we extrapolate where all of this is heading, there is a scenario we need to be prepared for based on this source material. We know attackers are hijacking premium cloud nodes to quietly proxy emails and borrow corporate reputation. But consider the current landscape.
Okay, what are you thinking?
Organizations today are routing massive amounts of highly sensitive internal data through these exact same trusted, interconnected cloud environments to train their proprietary artificial intelligence models.
Right, AI training data is everywhere.
So what happens when silent hijackers like PCPjack realize that email spam is small potatoes? What happens when they stop proxying spam and instead start subtly manipulating the internal data streams flowing through those compromised nodes?
Oh, wow.
They could poison corporate AI models from the inside out, slowly skewing decision-making algorithms or embedding hidden backdoors completely undetected. And it would all happen simply because the AI training pipeline implicitly trusted the data coming from an internal corporate cloud server.
Now that is a terrifying evolution of the threat landscape. They aren't just hiding inside the network anymore. They are quietly rewriting the company's brain while everyone is asleep.
Well, thank you for joining us for this deep dive. Check your forms, aggressively monitor your outbound traffic, and turn off web dialer. Stay safe out there.